Okay, here with a quick video that covers various topics from a seventh grade final review sheet. So let's dive right in. Looking at this one, how many solutions does each equation have? Well, it's important to recognize that often these solutions will be of the following variety, where you have sort of an x term on one side and x term on the other side, and also a constant on one side and a constant on the other side. And I think the thing to note is that if the x terms are different, in that moment, you immediately know there's one solution. Okay. If the x terms are the same and the constants are different, okay, these are the same, then in that case, we would say that there's no solution. And if it's the case that the x terms are the same and also the constants are the same, then we would say that there are infinite solutions. And hopefully we're all seeing that, if you have an equation, you might have to kind of get this side to look a little something like this. You might have to get this side to look a little something like this. That way you can make this comparison that I'm talking about, and then you'll know what you're dealing with. So let's dive in. How many solutions does this thing have? Well, right away, of course, we have the opportunity to combine like terms here. We would have x plus 13.5. We have the opportunity to combine like terms here. That would be x minus 13.5. So this is a scenario where the x terms are the same, but the constants are different. So therefore, that is no solution. Over here, we have the opportunity to combine these like terms. Of course, that would become 2x plus 12. Over here, we have the opportunity to distribute. So that would become 2x plus 12. It's the case that the x terms are the same and the constants are the same. So, of course, that is infinite solutions. And then finally, we have the opportunity to distribute. This would be 12x plus 18 minus 6x equals this thing. And sort of simplifying, the left side would be 6x plus 18. Immediately we can see that this x term does not match this x term. And in that moment, that's all we need to know that there is one solution. Okay, so that's that. Problem number 4, the weight of blah, blah, blah can be found using that expression, okay, where x is the number of weeks, okay? The weight of Karen's dog could be found by using this, where x is the number of weeks. Will the dogs ever be the same weight? In other words, could this weight ever be the same as this weight? That is sort of the question, okay? Now, obviously, I think my student watching understands that we're just going to do the same thing, right? That we just did. Distribute, 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 distribute. Of course, 2x plus 6 equals 3x plus 3. So, yeah, so the x terms do not match. Therefore, there is indeed one solution. So, in other words, there is some amount of time that could pass or that would pass such that the weight would be the same. Okay. So that is how you do that one. Let's move to the next. Okay. So the graph shows the proportions of blue paint and yellow paint that Brianna mixes to make green paint. What is the slope of the line? Tell what it means in the problem situation. So for my student watching, I feel pretty confident that you're probably going to get the proper slope of the line But unfortunately, I think the glare of the photograph that I took of the review sheet is making it so that I can't really see these lines too well. I'm going to just give my best guess now for my student watching. Just know that the actual answer might be different than what I'm about to say. But as far as I could tell, it does seem like this is kind of going up and this is sort of meandering its way over. So it kind of looks to me like the point 0.7 comma 6 exists on the graph. And it's also true, of course, that this is 0, 0. Now, what that means is that, the line is going 6 up and 7 over. And that means that the slope is going to be rise over run, right? So that would be 6 over 7. They ask, tell what it means in the problem situation. Well, this person is mixing paint together to get a particular color. There's a certain amount of yellow paint the person is mixing with a certain amount of blue paint. So I think we all understand that for every 6 units of yellow paint, this person is mixing in 7 units of blue paint. So that's essentially what it means, what the slope means. Okay, looking at the next problem is a mixture of nuts contains 1 cup of walnuts for every 3 cups of peanuts. Write a linear equation that represents the relationship between peanuts X and walnuts Y. So, yeah, peanuts will be the green X and walnuts will be the yellow Y. So, I think the way I would go about it actually is to think of the graph. So, whenever walnuts are at 1, peanuts will be at 3. So, it's the case that that point should exist on the graph. And this is a proportional relationship. So the line would go from the origin like that. And then we have to sort of just ask ourselves, what is the equation of this line? Well, I think my student watching can see that, if we were to use y equals mx plus b, well, the b is clearly the y-intercept. Hopefully my student watching remembers that. In this case, the y-intercept is 0. So you can kind of update the equation to reflect that. And at the end of the day, you don't really need to write that. So you could say y equals mx. And then really the only question that's left over is what is the slope? I think the slope we could see is rise over run. So it's up 1 over 3. So the slope would be 1/3 x. Yeah. Yeah, I think that should make sense. Um, and just sort of double checking for every 1 cup of walnuts, for every 1 unit of y, we're going to have 3 over here. Yeah, so I feel pretty good about that one. So that's one way of reasoning through that. Now, for my student watching, your teacher may have given you like a different approach here. I could see how maybe you could even use like a proportion to figure this out. You could have put walnuts over peanuts and then put y over x and then set that equal to 1 over 3. So you could have kind of done something like that and then worked with this proportion. But I don't know. I mean, the way that my brain works, I kind of like having the visual first and then just translating that into the equation. So anyway, that's how you do that one. Okay, looking here, um, is A, B, C similar to A prime, B prime, C prime? Well, it is certainly the case that side angle side would apply to this, meaning, if we could find out that this red side is proportional to this red side, and if we could find out that this blue side is sort of proportional to this blue side, that would actually be enough to know whether or not the triangles are similar, because the angle in between these sides is the same. However, I'm not so sure for my student watching that you've um, gone that far where you've discussed side angle side. I feel pretty confident that the teacher probably talked about side, 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 where perhaps the teacher insisted on you finding out whether or not this green side is also proportional to this green side. And I could see that. So let's see. Let's see what this example does. Yeah, it looks like the example is comparing literally all the sides. Hmm. Okay. We'll just do that. So essentially, what we're really checking is we could put all like the side lengths pertaining to this smaller triangle on the top and all the side lengths pertaining to this larger triangle on the bottom. So we're going to basically compare regular AC to A prime C prime, and we will compare that to AB over A prime B prime, and we will compare that to BC over B prime C prime. And maybe we could just be very organized about this. AB is going to equal a certain length. You know, AC is going to equal a certain length. BC is going to equal a certain length. It's also true that A prime C prime is going to equal a certain length. A prime B prime is going to equal a certain length. B prime C prime is going to equal a certain length. AC, you can literally just count. That's going to be 1, 2, 3. So that's 3 units long. AB, you can literally just count. That goes 1, 2, 3, 4. So that's 4. Let's do the easy stuff first. This is going to require the Pythagorean theorem. So why don't we just kind of hop over to this one? A prime C prime is a matter of counting also. That's going to be 8 minus 2, which is 6. This would be 10 minus 2, which is 8. Okay, great. Hopefully my student watching recognizes that the small triangle kind of sort of looks like this, where that's a 3, that's a 4. In order to find BC, which is this green one, I think we would agree that that's going to be 4 squared plus 3 squared, and that equals BC squared. That's going to be a 16 plus 9 equals BC squared, and then of course that's 25 equals BC squared. Taking the square root of both sides, we would get 5 equals BC after taking the square root of both sides. So that's a 5. I think my student watching recognizes that the larger triangle kind of sort of looks like this. We have this green one. I think my student watching understands that this is 8, this is 6, and this is, B prime, C prime right there. And that would be 8 squared plus 6 squared equals B prime, C prime squared. And let's just kind of be lazy and copy these, because I know I'm going to have to do that. Yeah. And then this would be 64 plus 36, and that's going to be 100. And then taking the square root of all sides would give us 10. So that's 10. And I think my student watching understands we could just kind of fill in these characters now, right? In a sense, we already gave ourselves the game plan over here. So let's go ahead and do that. The question is it true that 3 over 6 happens to equal 4 over 8? And does that happen to equal 5 over 10? Well, the answer is yes, because 3 over 6 is really 1/2. 4 over 8 is really 1/2. And of course, 5 over 10 is also 1/2. So yes, these all do indeed equal each other. So, these triangles kind of pass that test. So that is the answer to that one. I'm going to erase all of this and copy this and kind of bring it down here for the next part. What sequence of transformations shows that this triangle is similar to that? Well, first of all, we already know that the triangles are similar. We already established that. But they are asking for a sequence of transformations that show that ABC is similar to A prime, B prime, C prime. I think a good idea would be to follow the trajectory of point A and ask ourselves, how did this point A go through various transformations and then become A prime? Now we can kind of see from the figure that this thing flipped over the y-axis and then something else happened after that. Okay. So that flipping over the x-axis is a reflection. Okay. So, the point -4 comma 1 ended up getting, reflected. We'll call it xy. It ended up getting reflected over the y-axis, and that would be represented as -x comma y, where the sign of the x coordinate changes. So in that moment, what used to be just regular, point A became, we'll put this point here, became 4 comma 1. Okay, now in that moment where it flipped over the y-axis, it became 4 comma 1. It became this point, right? But then somehow this yellow point became this A prime. And I'm going to say that what happened was it went from an x coordinate of 4 to an x coordinate of 8. And it went from a y coordinate of 1 up to a y coordinate of 2. So it seems like the x and y coordinate of this point doubled. Okay, now what that means is that this triangle, after it had gotten flipped over, got hit with a dilation with a scale factor of 2. Okay, so it doubled. So, in other words, this point then got multiplied by 2. So that's a dilation. Okay, and then it became, we'll call this the red point. It became 8 comma 2. All right. Now, if you wanted to confirm that this series of transformations happened not only to point A, but this series of transformations also happened to point C in order to turn it into C prime. This series of transformations also happened to point B in order to turn it into B prime. You can always confirm that yourself, but it is the case that they just kind of want the sequence of transformations that I guess would show that ABC is similar to A prime, B prime, C prime. And I feel like this kind of answers it. Um, but it's also maybe the case that the teacher wants you to actually spell it out as well, literally with words. So you could say reflection over the y-axis. That's what this represents. And then you could say after that, there was a dilation by a factor of 2. So I do believe the teacher would be happy with that. Okay, so that's how you would do that one. Points C and D represent the location of 2 parks on a map. Find the distance between the parks if the length of each unit on the grid is equal to 25 miles. Oh, yeah. Okay, so no problem. This is -2 comma 2. And this appears to be 4 comma negative 1. And great. So let's see. Hmm. Well, you could use what's called the distance formula, but I have a feeling, because my student watching, you had mentioned a few times the Pythagorean theorem, there is sort of a clunky distance formula here, which I can't remember if we went over that. So I don't know if this rings a bell. Funny enough, this really is sort of the Pythagorean theorem in disguise. But I think I do remember that on your notes, there was sort of this picture of like drawing a triangle and maybe acknowledging that, this length right here is clearly 3 units, right? And, this length right here, I think you would understand is clearly like 6 units long. So, in a way, we're just dealing with a right triangle where that's 3 units long and that's 6 units long. And, we want to know what is this yellow distance, that straight line distance between the two parks. So that's this. And for my student watching, I think you understand, of course, we could call that C, that's going to be 3 squared plus 6 squared equals C squared. 9 plus 36 equals C squared. And then, of course, that is 45 equals C squared, taking the square root of both sides. Would, in the calculator, give us approximately 6.7. I'll use these fancy squiggly lines for approximately. The thing is, though, that each unit represents 25 miles, right? So we have to multiply that by 25. Okay, so that would be 167.7 ish. Okay, so 167.7. So that's how you would do that one. Pretty sure I got that right. Hopefully, I did not make a careless mistake. Let's bring this over, find the perimeter of ABC. Yeah, so for my student watching, simply find the length of the red one. You could just count in that case. I think it's probably 6, but again, this is hard for me to see. And of course, find the blue one by just sort of counting. And then just use the Pythagorean theorem to find the yellow one. And then once you have that, you can add all the lengths together, and that would give you the perimeter all the way around. I'm sure you agree with that. So that's how you would do that one. Um, triangle JKL is an equilateral triangle with 2 of its vertices on points J and K. What are the coordinates of point L? Round to the nearest tenth as needed. Yeah, so once again, unfortunately, because the picture kind of got rid of these grid ends, I'm just going to have to talk about sort of how to go about this. What we could do is simply find the length of this thing, which appears to be, I guess, 6 units long, right? Now, we might not know much about this blue point, but we do know that it's perfectly in the middle, so I think this starts at 3. So that would bring us over 3 units, right? Um, so interestingly enough, this is um, an x value of 6, not to be confused with the red 6. This red 6 represents how long it is, how many units there are across. This green 6 represents the actual x value associated with this point. So I will actually label that 6 comma something. Now, let's think about it. I'll make this green too. Now they are asking for the coordinates of point L. So really all our, the only mission right now is to, find this y coordinate, right? So, what would be a smart way of going about that? Well, here's a smart way. We could only pay attention perhaps to this yellow triangle right here. And I'm going to draw it off to the side. And hopefully, my student watching recognizes that is indeed a right triangle. Okay. And it's the case that this is 3 units long. Okay. Because that's going to be half of 6, right? This whole thing is 6. So half of 6 is clearly 3. And I think one of the main insights you need for this problem is the fact that you need to recognize that this whole thing is going to be 6 because, they told us in the beginning that it's an equilateral triangle. So that means that this is 6, right? So that's a 6, right? Because literally all 3 side lengths are going to be equal to this side length, right? And we already knew just from counting that that's 6 units, if I'm counting correctly, right? Again, the picture is kind of screwing up the XY coordinate plane for me. But nonetheless, we could call this B, right? And couldn't we just do a thing where we just do the Pythagorean theorem and then we find out what B is? And that would be like really helpful, all right? So we have this blue line that corresponds with this. If we just found out how long that blue line was, I really feel like we'd be on our way. So you have to understand that that's going to be 3 squared plus, and you have to be careful. That's B squared equals 6 squared, right? So that's going to be 9 plus B squared equals 36. And, 36 minus 9 is 27. And then B is going to be equal to, well, I should say, B is going to be approximately the square root of 27, which is 5.2. So it is the case that B equals 5.2 or is approximately equal to 5.2. So we're just going to call this 5.2. Now you want to be careful because you don't want to just say, oh, that's 5.2. No, because the length of this blue thing is 5.2. But we also have to take into account that it also goes 2 units up here, and then it goes 5.2 up. So this, I think my student watching agrees, is going to be 7.2, right? It's going to be this blue 5.2 plus these 2 units right there. And that would actually give us this y coordinate. So that is how you do that one. Okay, so Mark has a $100 gift card to buy apps for his smartphone. Each week he buys one new app for $4.99, and that's basically $5. Write an equation that relates the amount left on the card y over time. Okay, this time I'm not going to rely on the visual right away. I would like for my students to, once again, remember that the equation of lines, and I think this probably will be a linear equation. Let me look at the example here. It looks like they're kind of focusing on linear equations here. So what they're probably looking for is for you to remember this whole slope-intercept form. Okay, let's keep in mind that that's the y-intercept. This is the slope. And I will just tell my student, maybe you remember this from class, but anytime they give you sort of a starting amount, whether it's an amount of money that you have at the beginning of the process or something like that, some kind of starting amount, that is often, if not always, going to be the y-intercept. So let's just update the equation accordingly, where we know that the starting amount is 100. Now, the slope always represents the rate of change. It's like for every unit of time, in this case, weeks, for every single unit of time, how much is the amount going up or down? Well, if this person is spending $4.99 per week, that means that the amount of money this person has in his possession is going down by $4.99 per week. So therefore, I think my student watching would agree that it's going to be negative 499 times however many weeks go by plus 100, which is again the starting amount. Now, a couple important things. Not only do you need to be familiar with the fact that the y-intercept corresponds with the starting amount, it's also the case that this person's losing money or spending money, we could say, right, every week. So the slope's going to be negative, right, because y represents how much money this person actually has in his possession. So I feel like we totally just satisfied that one. Now, it looks like what this section is inviting you to do is to use a table. So I'm going to say, let's go ahead and do that. We could have our, what is it, x on top, y on the bottom, right? So we have x and y. And you can indeed use a table. That could really help you sort of graph the situation. I'm going to say let's use the x values that they provide. Here we have 2, 4, 6, 8, and 10. So 2, 4, 6, 8, 10. And then it's really just a matter of plugging 2 in for x and seeing what you get. So I'm going to kind of demonstrate just that one right now. If you were to plug 2 in, it would be y equals negative 4.99 times 2 plus 100, right? And I think for my student watching, I think you had mentioned that you're allowed to use a calculator. So I'm going to use a calculator for this. Now, worst comes to worst, if you can't use a calculator, yes, you're just going to have to work this out, unfortunately, and then add 100 to the result. So this is going to be $90.02. So I'll write that here. And I'll just say that when you plug 4 in for x, I'll just tell you what that is in my calculator right now. If you were to plug 4 in for x, that would be $80.04. Okay. And in my calculator, if you were to plug 6 in for x, that would become $70.06. If you were to plug 8 in for x, that would be $60.08. If you were to plug 10 in, that would be $50.01. Okay. So then plotting those points, one of the points is 2 comma 90.2. So I think my student watching would agree that's going to be like something like that. The next one is 4 comma 80.04. I think my student watching would agree that's going to be like right there. The next one is 6 comma 70.06. So that is, going to be here-ish. 8 comma 60.8.08. Clearly that's right here. And finally 10 comma 50.01. And obviously that's going to be right around there. And also we started at 100. So the line, if we're going to graph it as a line, would look like that. Now I would actually kind of dispute this in the big picture because the reality is, this person every week it just shoots straight down by $5 and then it's like goes across and then it shoots down by $5 and then goes across and then it shoots down by $5 and then goes across, shoots down by $5. So to me it actually wouldn't be a line, but I think what the teacher's looking for is for this to be a line. For my student watching, maybe just double check that this should indeed be a line. Okay, kind of like this one, right? So anyway, that is how you do this one. Hopefully that all makes sense, and I will talk to you all later.